Hello everyone. So in this video, we are going to discuss the first problem which came in BMath 2008. So the problem says that you have a function f from R to R, which is a continuous function. And suppose that you have f of x is equals to 1 by t, integration 0 to t, f of x plus y minus f of y dy for all x in R and t greater than, and for all t greater than 0. Then we have to show that there exists a constant c such that f of x is equal to cx for all x. Okay, so let's get started. So here we have the equation f of x is equals to 1 by t 0 to t f of x plus y minus f of y dy. And now we can easily take that t on the other side, and now let's differentiate this equation with respect to t. So f of x will be treated as a constant here, and then you'll be getting f of x plus t minus f of t. And now notice that this happens for all t greater than 0. Okay, and so since f is also given to be a continuous function, now if we let t tend towards 0 from the right hand side, then what we have is f of x is equal to, so if t tends to 0 from the right hand side, then that would imply f of x is equals to f of x minus f of 0. So which implies that f of 0 is equals to 0. Okay, so this is a very nice thing that we got. Now, the next thing is that, so if you notice that f of x, which is equal to 1 over t integration 0 to, if you just change the variable to x plus t, so you can write f of y dy minus 1 by t 0 to t f of y dy. So from here we can simply say that this implies that f of x is differentiable. Okay, so let's use the definition of differentiability. So we have f of x plus t minus f of x divided by t. Now look at this thing. What does this become? So let's try to use this relation here. So f of x plus t minus f of x is nothing but f of t. So this is f of t minus t by t, which is also equal to f of t minus f of 0, because f of 0 is 0 divided by t. And now if you let t tends towards 0 from the right hand side, so what we have is that would imply that f dash x is equal to f dash 0, and thus we get that f dash x is some constant. Okay, so let it be some c1, or maybe let it be some c. Then if we just integrate it, so we get f of x is equals to some cx plus d. But you see that the thing is f of 0 is equals to 0, so which implies that f of x is equals to cx for some constant c. So for some c in R. Okay, since f of 0 is equals to 0. And so we are done. Thank you for watching. See you next time.